The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. And now, the man who takes the BS out of BS, Bill Spohn.
Hello, everyone, and welcome back to the Building HVAC Science Podcast. We hope you're getting something out of these sessions that we're doing here, and we'd like to continue to do more. Building HVAC Science Podcast is a proud member of the Blue Collar Roots Network, which consists of the HVACR School, HVAC Tool Pros, Service Business Mastery, and HVAC Shop Talk, as well as a new one called Rather Be Fishing and Power, Paint, and Wash Academy. So go take a look at these podcasts. I think you're going to get some very interesting information out of them. Well, I'm your host, Bill Spohn. Why I'm doing this? Well, we're helping to try to fill the skills gap in the blue-collar trades through training and communication. And it's a passion of mine to do a lot of communication and training. I do it coast to coast around the country via webinars, via articles that I write, via in-person presentations. So today we're going to cover a topic that's going to be something that we often get questions on. I'm also the owner of True Tech Tools. And at True Tech, we sometimes get questions about products. People aren't sure that they're working correctly. They want to make a return. Things just aren't working out for them. Well, today we're going to talk about infrared thermometers. So the infrared thermometer is sort of like the cyclops or the one eye from a thermal imager. So if you think about a thermal imager, you all seen thermal imagers are coming into some really low price points lately. So a lot more people are using them. I'm seeing them all over Facebook a lot. A lot of our followers are using them. So they're a really great tool to paint a thermal picture. And a lot of times thermal pictures can tell you what's going wrong with the system and basically paint a heat picture of what's going on with the system. Infrared thermometers have something that's called a distance to spot ratio. The simplest way of understanding that is imagine if you're 8 inches away from a 1-inch spot on the wall. If your infrared thermometer has an 8-to-1 distance to spot ratio, it's going to see just perfectly that 1-inch spot on the wall at 8 inches away. Nothing more, nothing less. If you draw in a little bit closer, it will shrink to a smaller diameter than that and show you a little bit more refined area. However, if you back up and you're interested in seeing something that's about 12 inches in diameter, you want to get the average temperature of this thing that's 12 inches in diameter, and you back up away from it. With an 8-to-1 ratio, if you're 12 inches away from a 1-inch spot, you're going to start to overlap and splash over and see other things you weren't intending to see. And it gets worse. If you go to further distances away, say 30 inches away, you're looking at a 1-inch spot with an 8-to-1 resolution, a distance to spot ratio on your infrared thermometer. You're going to end up with a large overlap of background thermal information. That's not going to be very helpful because that's not the spot you were intending to measure. So one important thing to keep in mind with infrared thermometers, and there's several things to keep in mind we're going to talk about here today. One of them is distance to spot ratio. You got to make sure that matches up with what you're using. A second topic you got to keep in mind with infrared guns, sometimes they call them infrared thermometers, is you're trying to look at a spot that's usually a circular pattern. Now, a lot of the devices have a single dot laser, and that single dot laser is only going to paint the center of the circle that you're looking at. It won't be telling you anything about how big of a spot you're measuring. Now, fortunately, there's some devices out there, and actually Testo makes some, as well as other manufacturers, that you'll find they actually paint the outside of the circle that you're measuring, so you know exactly what you're getting when you make this measurement. The distance to spot ratio is one thing that's important. Make sure you're the correct distance away. The second thing that's important is make sure you know what you're measuring, and that center dot is not. The dot is not what you are interested in measuring. If you have a center dot type laser, it's not really a laser thermometer. It's a laser pointer attached to an infrared thermometer. Another point to keep in mind is something called emissivity. Now, emissivity is the property of a surface to reflect thermal or infrared radiation. most infrared thermometers have adjustments for emissivity. If yours does not have an adjustment, sometimes they say sort of like shiny and bright or dull and light or something like that, or maybe have one switch. Some of them allow you to actually dial in a full range of emissivities. Something is called a property of something to actually radiate all its thermal energy. It's called a perfect black body radiator. So it will actually emit only the energy from its surface. It won't reflect any energy from anything else. But if you've run into something that is not a perfect black body, and usually perfect bodies, they're hard to come by. If you have something that is not a perfect black body, it will actually reflect some of the thermal energy that it's picking up from the room, from the surroundings, from other objects nearby. That reflected energy is going to actually bounce off the surface and come back to your infrared thermometer. And when it does so, that's going to add to the thermal energy that it thinks it's seeing from the object that you're trying to measure. So now you've got this additive factor in there. So you have to sort of dial out that. Fortunately, most building materials, paints, surfaces, things like that, have an emissivity of about 0.95. That means they're mostly or almost nearly perfect black bodies. And sometimes that's the setting on more of a generic type infrared gun. It will be set at 0.95 for emissivity. So you have this effect of the energy coming from other objects bouncing off and hitting your infrared thermometer and giving you a false reading. Now, not everything that looks shiny to the eye is shiny in infrared, but things like copper, aluminum, steel, paints, certain other surfaces can be actually very emissive and will actually reflect a lot of the ambient temperature back to your device and give you a bad reading. So that's another factor to keep in mind is emissivity setting. You need to know what your emissivity is. There's a lot of lookup charts online for it, but one good practice is you can actually take a black tape and tape it to a surface. Now that tape's going to be a little bit of an insulator, so it's going to not be reflecting actually the exact temperature of the surface, but it'll be almost the same temperature of the surface. So if you have a copper pipe and you hit it with a piece of black tape and measure the temperature of that pipe where the black tape is, and again, being careful about your distance to spot ratio, make sure you know what you're measuring and you're not overlapping other things in the background, you're going to get a pretty good readout from that black tape, sort of giving it more of a black body type perspective to it. Another factor, we talked about the laser dot, is not the measuring area, and you want to make sure that you can paint or see that full measuring area or visualize it somehow to make sure you're measuring what you think you're measuring. An infrared device actually detects surface temperatures. So if you're trying to read something like water, that's going to be difficult, flowing water. If you're going to try to read something like the temperature of air, that's going to be difficult. You could point your thermal or your infrared thermometer at, say, a grill that's a supply or return grill. And if you have enough airflow over that grill for a long enough period of time, that grill is going to be just about at the air temperature. So you're going to get a good approximation of that. If you don't wait long enough, and I've seen some videos recently of some different products out there where they're taking these spot infrared measurements immediately when they turn the system on, they haven't allowed it a chance to equilibrate, to have all the grills and surfaces catch up to things. That's not going to be a very good reading. If you're not aware of these 3 points, that would be pretty frustrating if you're just given an infrared thermometer and you try to use it and you're not paying attention to the distance to spot ratio. You're not paying attention to the sort of the painted area that you're measuring. You're not aware that that laser dot is not where you're measuring. And you're also not aware of what emissivity means. But if you put all this knowledge together, you're going to do a better job using infrared thermometers. Okay, let's wrap up what we learned here today. Let's call it 4 important points. One is target right. Make sure you know the size of your infrared target. Second point is the dot is not what you're measuring. Third thing, know your emissivity. Or if you don't know your emissivity and you suspect it might be off, then use a piece of black tape, but also make sure you're targeting right on that black tape. Fourth point, infrared measures surface temperature only. You can't measure the temperature of fluids, gases, air, things like that. Now that we've covered those subjects, hopefully you'll go to work using your infrared thermometer a lot more intelligently. Again, that's our goal here, is to help you understand the HVAC science and the tools and measurement aspects of the science. You may wish to also take a gander at some of the other podcasts that are part of the Blue Collar Roots network. And you can find that very easily if you go to bluecollarroots.com. You'll find a listing of all the other podcasts that we have going. So we're also looking for your feedback, suggestions, ideas for topics. If you want to reach me, you can reach me at bill_Spohn, S-P-O-H-N, at bluecollarroots.com. That's my email address. If you're interested in obtaining any of the products at TruTech Tools, you can go to trutech.tools.com, TRUTECHTOOLS.com, and you can use the discount code HVACBS, that's HVACBS, and receive an 8% discount off your order. So we look forward to seeing you back next time at the Building HVAC Science Podcast. Please drop us a line if you have any questions. Take care.
The best way to listen to this podcast is by using your smartphone or other web-connected device and subscribing using the podcast app on Apple devices or the Stitcher app or Google Play Store for Android devices. You can find all our shows on the Blue Collar Roots Network by going to bluecollarroots.com. From all of us at Blue Collar Roots, thank you for listening.